Okay, one of my most favorite topics is graphing. Just like most things in this workshop, where this is a surface level basic introduction to get you like, oh, here's how I would start doing it. So this is not the end all and be all of R. This is not going to be the end all and be all of all the fanciness that ggplot can provide. It gives you a place to start. So there are sort of three main plotting systems in R. When you first download R, you could type plot and like we could plot the Gapminder data set and it will plot using what's called base graphics. Base meaning it just comes with base R. Then there's a package called Lattice, which like back in my day when I was learning R, that was like the thing to use, and it provides another framework for graphics. Then came along this dude, Hadley Wickham, who wrote his PhD thesis on this concept of grammar of graphics, which is where this plotting package came from. I can't say it revolutionized it. We're focusing on it, or we're learning it mainly because it's the most effective way of making almost publication quality graphics with very little code. Now, when you need to get in there and customize and tweak and add little tiny things, sometimes you may have to go back to base. But like ggplot provides really nice standard graphics with very little code. Makes a lot of assumptions for you, but that's okay. We call it it's referred to as a grammar because there's three main components to it. So it has a structure. You always specify the data set you're going to use. Then you have these things called aesthetics or mapping aesthetics. That connects the grammar, the data that's in the data set to the graphics themselves. What's going to be on the x-axis? What's going to be on the y-axis? Are we going to color certain characteristics? Or are we going to make multiple panels? Like, how is it going to be structured? Those are like this, or what's it going to look like, right? Aesthetics. Then we add on layers. And layers are like the graphical, the actual, like the boxes or the points or the lines, or the coordinate system, or we're adjusting the x-axis, the labels, or the all the different like add-on tweaks that we use to make the graph what we want. So we are working in ggplot2. So to access those functions, we installed the ggplot2 library last time. We only do it once per R session, but every time we want to access it in a new script, we have to load the library or load the package. This only happens, it only needs to be happen, we only need to load the library once per script, right? So to start making a graph, first we need to specify the data. All right, so our main function is ggplot. The package is ggplot2 because it's the second iteration of it, but the function itself is ggplot. And our first argument is always going to be the data set, and we're working with the Gapminder data set. Now, if I run this code now, just ggplot, this blank gray box shows up in your plotting window in the bottom right-hand corner. So you're telling R, hey, I want to create a plot and it's going to be on the Gapminder data, but you haven't given it any other information yet. So it's like, great, here's a plot window that's blank. So what we need to do is add those mapping aesthetics. So we're going to copy the code we had before. And inside the ggplot function, we're going to add a mapping argument. And we're going to say mapping equals AES. AES is for aesthetics. And I want to put the variable GDP per cap on my X and life expectancy on the Y. Again, you can copy this from the learner notes. But notice as I was typing, RStudio was trying to be helpful and giving pop-ups. If I submit this line, I still have a blank graph, but it's put the GDP per capita on the x-axis with numbers and life expectancy on the y. So we've mapped two properties, what's on the x, what's on the y, to the graph. And now we need to add an appropriate geometry, right? GDP per capita is numeric, life expectancy is numeric. And if you recall from the statistics class or data analysis class, comparing two numeric variables, we use a scatter point, a scatter plot. The shape of the thing that gets put onto a scatter plot are points. So we're going to add, with the plus sign, a geom point layer. So we have our data set, we have our mapping, aesthetics, and then this plus is when we start adding layers. The first layer I'm adding is points. I don't need anything in this parenthesis because I've already specified what's on the x and what's on the y. So it's going to look in the data set, and for each row, figure out what's on the x coordinate, what's on the y, and put a point there. That is the fundamentals of how ggplot works. So I'm already giving you a challenge now. Change that figure. So like copy, we'll put a little spot here. Challenge 1. Copy your code, because don't try to reinvent the wheel and type it again, just copy it. Now modify it so that we're looking at how life expectancy changes over time. And the Gapminder data has a variable called year that if we're looking at a change over time, year would be on our x-axis. The green stickies when you got it. Red stickies are x's. And we got we'll have another challenge in there in a minute. Or now if we're good, we can add the second challenge in. Okay, again, so the first challenge is we're going to take our code, which currently plots GDP per capita on the x and life expectancy on the y, and changing this to be a plot of GDP per capita or life expectancy over time. I see some green in the room. We got 4 people on Zoom that have got this. 6, 7. We're getting there. We got 36 people. I know more than a third of you can figure out how to change this to be plotting over time. Yep, Ryan, exactly. We're going to change the X to be year instead. Not a super helpful, or I should say informative plot, but that's a different question. ggplot has done what we asked it to do. We asked it for for life expectancy with time on the x-axis and with a point geometry. So we have a scatter plot here. If Gapminder is not found, then you did not read in the data set, perhaps? So the second challenge is saying, so we use the aesthetic function to tell the scatter plot about where X and Y was. These aesthetics, let's go ahead and copy all this code again. Challenge 2, color the point, so add a color aesthetic to color the points by continent. Oops. So modify your code to that last challenge to color the points by the continent variable. So we can, in our aesthetics, we could add another color, and Hadley is from New Zealand, so you will see color with OUR and color without the U. Or you just go, oh, I think. Color is by continent. Magic legend appears. This is some of the nice things about ggplot is like it gives you don't have to manually create a legend. If it detects you're adding an aesthetic, adding a feature that like you're coloring by something, it will give you the automatic key and legend for that color. So something that you might notice is in the notes, we've got all of this on one line, almost all of this on one line. The data, the mapping. Yeah, in my code, I put mapping on a different line. And so this is kind of just like a stylistic, it's formatting the code for readability, and there'll be some more examples in the learner notes. Instead of just having your code try to be on one line all the way across the page, you can, like after a comma for like a new argument, data gapminder, mapping is this aesthetic, and now here's my geom. You can even, inside the aesthetic statement, I've seen people put each like argument on a new line as well. This is part stylistic, but in general, think about readability of code. Yes, we can read a sentence without spaces between the words, but it's hard. So putting like especially new layers on a new line sometimes just makes it a little bit easier to read. So let's talk a little bit more about the layering. So as I kind of alluded to, scatter plots may not be the best thing for detecting changes over time. Often we'll see that as a line plot. So let's try that. Let's take our last challenge code and copy it. And instead of a point, let's change it to a line. Let's see what that gives us. And this is a kind of a key tactic for building graphics is you want to start small and change one small thing at a time. You look online, you find the type of graph you want, and it might have like 18 lines of code. And if you copy all of it in and try to adjust it, it may not turn out the way you want. Scale back to the bare minimum and then just change one thing at a time and see if it does what you want it to do. Well, we still have our color, one line per color, but it looks like it's connecting the dots. So connect the dots. La, la. But let's fix it. So we really wanted one line per country. How does each country's life expectancy change over a year? Again, I'm going to copy and paste. In production, I would not copy the entire code to another section and change one thing. I would just iterate on the same code. I'm copying it for demonstration purposes right now. So I want to change the lines. So it's one line per continent. So I'm going to add a group argument. There's also in the aesthetic, because that's changing how the lines appear. Hold on. Because it's not continent, it's country. There we go. One line per country. So I added the group aesthetic. There's tons of different aesthetics that you can add. Remember, this is kind of a quick overview of the GD2 plotting system. This is where looking at the vignettes and the help files and seeing examples and seeing what is the geometry I need for this? How do I group, how do I make this plot look like the way I want? The cool thing is that we still have, so now this plot actually has 4 different variables in it. We've got year on the X, life expectancy on the Y. We're coloring by the continent and have one line per country. There's a lot of good information here. To do this plot in base R graphics actually would probably be like 3 times the amount of lines of code. So great, we got our line, but I really wanted those points. So let's add back the points. And so each geometry is its own layer. So now I've added the points on top of the lines. So we're slowly adding up and making our graph more complicated, more detailed. So now those points, I mean, they're there, but what if, okay, now, what if I only wanted the lines colored, right? If I want to modify only one layer, not the whole thing. So in this code, our coloring is inside the aesthetic statement. If you put a aesthetic, if you put a feature, a definition inside that mapping, that initial aesthetic in our main ggplot function up here, I should say, anything you add to the main ggplot function will apply to all layers. If you only want to apply something to one layer, let's take out the color and let's put that mapping, where do I want to, yes, I want to put it in the line. Mapping. Let's add the aesthetic continent only to the lines, only to that layer of the lines. So my points are still black because I've never said to change them, but the lines are colored. So to reiterate, if you put a mapping, an aesthetic in the main ggplot function, it will apply to all layers. If you want to modify one layer, you add that aesthetic mapping inside that layer only. So now we have the colored lines and the black points on top. There's something else about layering that you need to be mindful about. So what I want you to do in this next challenge is to switch the order in your code of the points and the lines. Don't retype anything. I mean, you'll have to modify where your plus is at to change your layers. Swap the ordering and see what happens. You see what happened? Mm-hmm. But like, what happens if I do this is like the best way of learning how to code, especially like when building plots. Like, let's see what it looks like if I change the points to be colored by country. All right, what do you think happened if we change the order? So I'm looking at my Zoom crew here. What is different about this plot where we had the line first and then the point versus line? Mm-hmm. What about in person? Because you guys can't see the chat. The order in which they're drawn. Mm-hmm. So if I swap the order of line versus point, let's physically move this, add my plus, take off my plus. The lines are on top of the points now. Points should not be in color if you're still only changing the color of the lines. But we could totally only change color of points by taking out that mapping out of the lines and adding it to the points. That is kind of hard to read though. But that's how we figure out what's going to work visually in different graphics. Okay, so we've got let's go back and let me go back and look at this plot, right? There's a lot of countries in this data set, right? And so it might be easier to like, let's maybe pull out some continents and take a closer look at some of the country level behaviors over time. We're going to do this by looking at what's called a multi-panel. So like, let's take out some countries and let's like make one plot per country. There's a lot of countries in here. So the first thing I want to do is let's make a subset. I don't want to look at all the continents. Let's just look at Asia and Oceania. So I'm going to make a new data set, and this code's in learner notes, so please don't feel you have to type. Where I'm going to take the Gapminder data set and pull out, nope, not country, where the continent is either Asia or Oceania. And I need to add a column because I want all columns. I want those rows of the Gapminder data set where it's in those continents, but then all rows or all columns. See, it even told me undefined column selected. Now, let's grab that last code for the last plot we made, but change the data set. So instead of plotting Gapminder, I'm plotting my new subsetted data that only has 2 continents worth of data. And I'm going to simplify it and take off the points. Actually, I'm going to simplify it and take off the colors because I only want to focus on making one plot per country. And we use the facet wrap function for this. So what this is going to do is it's going to create that line plot where we still have year on the x-axis, life expectancy on the y, but it's one panel per country. And that's what this facet wrap is doing. And this little tilde, you might see that as like formula notation. It's like I want to wrap everything I did above here, do all of that per country. I want to do one extra thing on here because I really like those colors. Add color by continent. So I'm gonna just put that back. Where is it? Group, country, color, continent. So I still have that faceting, and I can see which of these countries are corresponding to which continent. So in this data set, I mean, there's a lot more countries going on in Oceania than New Zealand and Australia, pretty sure. But not any that show up in this data set. Like if we were to look at the globe, I think there'd be more in there. But for this data set, these are the only 2 that are considered in that continent. A lot of ability to tweak and adjust. Let's make this a little bit cleaner, a little bit more, I'll say, publication ready. I'm gonna copy it because I'm always copying my code. And I'm gonna add another layer called labs for labels, right? While life exp makes sense as a variable name, it doesn't, you wouldn't like want to give that. You wouldn't want to put that in a publication. So let's make human readable axes labels. So let's put year with a capital on the x-axis. Let's write out life expectancy on the y. Let's give it a title. Call it figure 1. And let's capitalize that continent color. Sorry, not the continent color, the name of the legend. So we've made it a little bit nicer to read. That x-axis, though, is really, really cramped. So there's this, I mean, there's so many things you can do to ggplot. And again, RStudio tries to help. Like, I want to modify my axis text on the x-axis. And like, do I expect you to, do I remember how to do, not Angel, that this is the magic, how about I spell angle right? That this is the magic code that I need to turn my years horizontally? Oh, do I remember how to Google it? Yeah. There's so, the amount, I have a mug, coffee mug that tells me, that shows a little the picture of Googling ggplot remove theme or remove legend, because I constantly forget how to remove the legend. And I've been working in this for like 10, 15 years. But I still Google that one specific. And so when I saw the coffee mug with it, I had to get it. And it's in my office. So there is so much tweaks and adjustments you can make. I'll show the in-person crew. There's this R graph gallery is fantastic. So it's like, I don't know exactly what the name of it is that I want, but I want something that looks like this. Okay, so apparently it's a lollipop chart. There's so many ads. I like this one. Great. Okay, it's a segment. Like, that's how we learn how to do this, is by finding an example and copying it and like reverse engineering, putting in your data, what you want on your X and your Y. And again, starting small. So like with all of this, I would start with these 2 lines. Make sure I can get my data in and my x-axis correct. Then we'll make the theme and add the points and the X label and all of that fanciness. And the cool thing, if you're multilingual, polyglottal, there is a Python graph gallery. So it's like, I know how to do this thing in Python. How do I do it in R, or vice versa? Great, we made a beautiful plot. Let's get it out in a Let's export it so we can give it to somebody else. Because we made it, we get to see it, fancy, but we made it for somebody else. You might notice this export button where you can save as image, copy to clipboard. Those look great for like internal, I just need something real quick and dirty. Internal audiences, you just need to save it for yourself later. You don't really, it's not going to like a journal. Or to, you know, like the executive committee or like the president or something like that, right? I would never export or copy an image, or especially if you're making graphs for a poster presentation. If you copy this, when it blows up, when it gets posted to printer size, oh, it's blurry and it looks awful. So we need a way to get the graph out as a high-res image. That's where ggSave comes in. So we just made this lovely plot. So the first thing I want to do is save it as a object. So I'm just copying all of that code and using the assignment area to save it as an object. Life expectancy, I'm going to call it dot plot. That makes way more sense. So notice we're not saving a vector or a data set, we're saving an entire image. Objects can be really nice and they can be complicated, which is beneficial. So let's say we've got it saved as an object, and if we wanted to see it in our environment, it's down here somewhere. There it is, life expectancy plot. All right. Now we're going to use ggSave. The file name, we're going to put it in our plots folder. So if you have not created a plots folder yet, do so. You can do it in your file window down in the lower right. Or open your browser, your Explorer window. And I want to call this life expectancy. I want to save it as a PNG. You could save it. There's PDFs, there's JPEGs, there's all the different file types, EPS. Specifically, I want to save the life expectancy. Ooh, I forgot that word. The life expectancy plot that I just saved. I just like saved as an object. I created the plot, saved as this object. This is the thing I want to put in that file name. And let's control the width and the height. I don't ever remember if these are inches or centimeters or what the dimension is in them. I tweak them until it looks right, and then I just remember the numbers that I like. Sorry, that's not very helpful. Well, okay, but we can specify, hey, look, we can specify the units. Centimeters, but I also want a DPI of 300 to make it really decently high res. So I run that code, and if I look in my plots directory, I now have this PNG file that, I mean, clearly needs a little bit. Yes, I do need to edit my image, but not with AI. Clearly needs a little bit of adjustment because I can't read the country names. Okay, so I'd go back, I'd probably move my legend to the bottom or the top, maybe control how many countries are on what column, or how many columns and rows I have, make the plot wider instead of square. These are all the fine-tuning things that you do once you get to that point where you're like, okay, I'm ready to export it for somebody else. No, I don't need a video editor either. Go away. It's bad when pop-ups are happening on a computer, not in a browser. Like, anyhow. So one last challenge. So that's how we get a plot out to save it. One last challenge for you that kind of goes back to the concept of a geometry, of a different geometry, and might make you have to Google something. Oh, where are my notes? Okay. So we have the life expectancy, and we have the different continents, and we have the different years. So right now, our plot is a line plot. Our geometry is a line across year for the different countries. You can ignore continent if you want right now. What about a box plot? So let's change it to comparing basically the distribution of life expectancy for the years that we have across the continents. So think about the variables we're looking at here. You're not going to necessarily be able to copy paste the whole thing from before, but we want a box plot. That's the shape of the thing we're going to create. We want continents for the available years, and make sure life expectancy is on your y-axis. And this is the last challenge for this section. Just kind of, again, kind of a quick overview of the coolness that ggplot2 is. But there'll be links to cheat sheets and vignettes in the learner notes. Let's do all the continents. Yeah, that is one of the things that we have to tweak when we're exporting a plot is the text size, because if there's going to be kind of a mismatch sometimes. If we have a really large plot, say I'm taking off say I'm going to make something for a poster, and so I want, like, I don't know, 20 centimeters width. Let's do 50 versus 20, something like that. Let's see what that looks like. Or is it DPI? Yep, okay, so everything's like super small now. I would adjust it in the theme here. Call it base, I think it's like base size. Is it that? Is it that? Let me see. No. Because I think it's another theme. I would have to, apparently not remembering, I would have to Google again, but yeah, you basically have to change the text size, but you can change it for the entire plot. Oh, that's what I was doing. So it is based on it. Oh, but it's once you apply it to like, oh, there's a bunch of these themes too that we didn't talk about it. Theme dark. So I was right here. Now it's monstrous. So that's pretty much what the tactic would be, is to change. I personally like theme minimal. Just well, I mean, but if I applied this to this one that I'm exporting that I made bigger, oh, okay. Well, why is it? Oh, because I'm using theme minimal, which gets rid of the background color. Now it's a little bit better. I can read it a little bit better. It's a tweak, run, check, tweak, run, check. It's an iterative process. Yes, you can absolutely use the export button to save as image and then adjust the size and stuff like that to it. When it's we haven't really talked too much about reproducibility, but anything that you do that is manual like this, like loading packages, loading data, exporting figures, anything that you do point and click wise isn't going to be reproducible for other people. So having the code, you know, say you have a script where you always need to update a figure and you hit run, you're going to want to know how to modify the script so that it automatically exports in a format that you want when you're rerunning the code. So there, again, absolutely, export button's a great way to start to get an idea of what your dimensions are, and then you can tweak it from there if need be. So there's always multiple ways to work, or multiple approaches. So thank you for that.
Visualize this.
Yes. Okay. So how would I do it? Robin's solution. Not really my solution. Would it be, I am not going to type all this in, I'm going to copy paste. Boink. Is this. So I would wrap on year and put continent as my, and notice I'm using, there's a fill. I could have used color. It would have colored the outside of the boxes. So this is one solution of using box plots across continents. Okay, so let's see, you wrapped on continent, but what is your, oh, you still colored by continent too? And you group by year?
Yeah.
So now this is happening because continent is a factor variable. And so it's on our x-axis also. And so it's leaving a line for America on every plot, even if we're not plotting America.
Well, when I imported it, I did string as factor equals true.
Okay. Do you have a continent on your x-axis? We put year on our x-axis. Is this more like what you have? And so I don't think we need the grouping of year at that point. Oh, yes, we do. Let's go back. Control Z is my friend. So yeah, this is a great, take this, shove it in the learner notes. It's a great example. All right, so we can even see the trend within continent now over time. We get to see not only the medians that change, but also the outliers. Looks great. Yeah, so that's part of our data visualization journey, is adjusting it to what we want to see. Cool. Like I said, that is the kind of a taste of what you can do in ggplot. I believe there'll be more info in here, again with links to other help files or other help techniques.